We're gonna get going with the first exercise of the day. Whoa, that's not what I want. Okay, here we go. First exercise of the day. Maybe in case you have AnyLogic up and you have any things opened, I want you to close them. One thing I would note, just as a point of advisory for your use, you'll notice where's my trusty yardstick? There we go. Here we have a star after the name of the model. That indicates the model's been modified. So if you see a star after the model telling you, I haven't been saved, AnyLogic has an auto-save mechanism, so if anything happens, chances are we'll have a recent copy of it, but it's still best to not only build, but save early and save often, okay? So there's been about 3 to 4 times in my life as a computer scientist working with, I don't know how many hundreds, probably 10,000 sessions of various programs. Only about 3 times in my life I ever regret having saved too frequently. By contrast, there's many times that I've saved too infrequently. So save early, save often is the rule of thumb. Okay. So let's go create a model here, and the model that we're going to create is going to be quite similar to some aspects of what we saw yesterday, but we're going to be undertaking it in a way that's more focused and that's worked out the kinks that we encountered yesterday. So I'd like you to go add a new model. So I don't think I have to ask you how we do that. We do File, New Model, and I'd like you to create the open population model, and you might want to call it Simple Open Population Model to contrast it with. Okay, that one already exists, so I'm going to call it Open Population Model NC. Okay, Open Population Model NC. Here we go. So Priyasri, you'll want to keep your eye out for things. First thing I'd like to do is I'd like to set the time unit of the model to be years. So to do that, we go to the model as a whole, and we set it to be years. We've seen this a number of times before. And then what I'd like to do is I'd like to create a person. So a new agent type called person. Again, not particularly privileged as a name. It's just what we'll be naming it. And I'd then like to go. We're going to add some features to this person for sex and ethnicity, and I'd like to go add those support for those in. So who can remember, if I want to have sex choose between male and female, make it quite explicit what those names are, what do I need to do? I need to add a options list. Okay, so I do new options list here, right? And I'll add capital SEX, and this will support female and male. Now, for those sick of doing this many, many times, I would note that in a real research project or other use of AnyLogic, you can actually define your own custom options list and put them on a palette that you could drag into your model. So you could have your standard sex options list and drag it in instead of redefining it every time. You could have your standard ethnicities that you use, and you could reuse those rather than defining them every time. We're going to have a singular ethnicity. Notice I'm labeling it with a capital E, and that's deliberately to distinguish it's sort of the general set of ethnicities. It's not a particular ethnicity, but a general set. So I'd like to add African American. I'd like to add Caucasian. I'd like to add Hispanic. And I think yesterday that's all we used, but I'll add Asian as well there. Reflection of shifting demographics, etc. Okay. So these are different ethnicities. Obviously, we could add different ones, and in your particular case, it will probably be somewhat different. Okay. So we've added these. That's great. But in order to associate a person with a particular sex and ethnicity, what would I need to do? So this defines ethnicityhood with respect to our model, or sexhood or sexness with respect to our model. What would I do to give a person a particular ethnicity? Yeah, so we have to add a parameter of that type. So double click on person, and let's add in parameters for sex, lowercase sex, because it's going to be a particular sex. And what sort of type is this? This is is it an int? Is it a bool? Is it a string? It's a sex, capital SEX. Good. And then let's add in one for ethnicity as well. Okay, ethnicity, great. And we'll place that in there. It'll be ethnicity, and that's good. Let's give this person a visual representation. I'll depict them as a person shape. Where do we do that? We can scroll down here and go down to pictures, and I'm going to depict them here in a person shape. We're not anticipating any need for sort of fancy coloring or what have you, so I dragged up that person shape. Later in the day, we'll be making use of some of these other icons. Okay? Now, the final element of a person that I want to add is one that we saw at the end of the day yesterday, and it was kind of muddled because we had encountered some challenges. Some of you didn't had a working model. Let's call it mother. Okay? This is going to be the person's mother. Person's mother. And what type is that? This is one of these things I don't want to be submerged by the confusions about functions yesterday or what have you. What type is this? It's a person. It's referring to another person. Often a person in a population, sometimes it's going to be marked with a null, N-U-L-L, which basically means it's referring to no particular person, presumably some person not in our population. Okay? It's some person outside the scope of our model, outside the boundary of our model. Okay, that's great. I'd like you to then go and take this from having defined persons. How are we going to define a population of people? Where do we go? Main. And what do we do to add that population? Drag from person in, and I'm going to call it population. What else do I need to do to make it a population? Okay, population of agents. And I'd like to make the population size depend on a parameter. A population size parameter. How am I going to do that? Okay, add a parameter to main, called population size. This is some parameter that specifies something about the whole model as a whole, not just about a particular person. If we're about a particular person, we might be tempted to associate it with a person. But here we're going to add it to the model as a whole. What sort of type is it? It's a integer. Good. Okay. It's an integer. Great. And we're going to specify for this a default value of 100. Okay. This default value is just a value that's given in case we don't fill it in ourselves. It'll be using that value. And where would we specify the value of population size? It'll be specified in experiments. Wow, you folks have learned a lot. Your sit-ups are getting really good, I tell you. Great. So now suppose we want this population to be laid out visually in a random way. Give me two ways that we can do this. We explored both yesterday. Give me two ways we can do it. I'll give you a hint. One is with main, one is with the population. Yep. A random layout type. We could do that. But we're going to do something different here, and it's for a reason, okay? This is one of the differences between AnyLogic 7 and AnyLogic 6 that threw me for a minute or two and inclined me towards creating a function, and it became more complex than it needed to be. Okay, so what we would like to do is, as an alternative, we're going to explore a different method. And then we say for the initial location, we're going to say we're going to specify them in a specified point. Okay? So we're going to the population, not to one layout, which is the default layout. Okay? It's the default layout. So we're going to put them, we're going to distribute them uniformly between 0 and 500. Okay? That's drawing a value from a continuous uniform distribution between 0 and 500. Okay? That's great. So we should be able to run this model, and we should be able to see something visually. So we're going to run it, and here we have people placed around the model. Okay, so who needs TA help? Who needs TA help? Priyasri is ready for incidents. Okay? System trouble incidents. Okay. Great. So we're much of the way along here. So now we need to specify attributes of the population. If we went and we looked at people right now, they'd be singularly uninspiring. Each individual is supposedly a set of that when the model doesn't have information on a particular person, when it's so-called uninitialized, it doesn't have the information filled in, each of these will be sort of grayed. Great, that's an indication you haven't provided a value properly, okay? So we're going to provide values. Where are we going to provide the values for people's sex, ethnicity, and their mother? Where would we provide that for the initial population, for the population that's there initially? Where would we provide it? In the population. Now, so remember, person class says that I have a sex, I have an ethnicity, I have a mother. It's a general feature of being a person. But the particular assumptions about those, the particular values to assume, those, ladies and gentlemen, are specified in the population. So we're going to go to the population here, and we see there are fields for sex, ethnicity, and mother. And we're going to draw a random sex, and we've done this before with random true. We're going to do it with a different way, just to make you, and both ways to do it is random from, and this is sex values. So what this is doing is, oops, there's no 0 there, sex stuff values. I'll put this up on the big screen so you can see it. This is what you have. Random from, this is capital F, and Java functions begin with lowercase letters here. And then in the parentheses, sex with a capital S. Note the capital, because we're saying we want all possible values of sex. This, therefore, has to refer to the general concept of sex. Sexness with respect to the model. Give me all possible values. This is a function call. That's why it has these parentheses here, saying, go off and give them to me. And it says, yes, ma'am. And it goes off and it gets them. And then we say we want a random one from there. Okay, great. That's good. Let's run the model and make sure that's working. Okay. Okay. Let's just run it. And now people should have sexes at least. Okay. Here's a female. Here's a female. Okay. Male, female, etc. So we should have a little bit different for this one. We're going to do something that's that we didn't see yesterday in the main session, although those of you who stayed for the later tutorial will have seen it, but it's a very nice feature, which is new to AnyLogic 7. We're going to add a custom distribution object, okay? So where do I add, from whence do I add that? I add it from general. And whither do I put it? I put it in person, okay? It goes in the person, in the main, not in person. It goes in main. It goes in main. And this is going to be ethnicity distribution. Okay. So what am I doing? I want to define a way to draw people's ethnicity according to some empirical distribution that I wish to specify. So rather than just saying we pick either any ethnicity with equal likelihood, we want to say, well, this one's more likely to be than that one. So we're adding a custom populate distribution, which is in the general tab of the palette, that very topmost tab, custom distribution. We're going to add it to main. okay? Because we're going to be using it in main to initialize that population. Who needs help of a TA? She stands ready. She sits ready. Okay? Great. Great. So this is a custom distribution, and now we're going to configure this. What does this custom distribution have to return? If it's going to be for ethnicities, ethnicity distribution, what sort of thing is it going to need to return? A value for an, yeah, it's actually, it is a type of discrete. It's a type of discrete indicated by an options list. So it's actually under options here, okay? So it's under options, and then it will ask us which options list are we specifying, the distribution with respect to which options list. And we're going to say ethnicity. And now we can go specify the relative frequencies of these different categories. Okay, so what I did is I selected type options, and then I selected the options list. And then you got data. I see. And it fills this in and data. It's asking me to fill in the relative frequencies here. How frequently we see African Americans, how frequently we see Caucasians, etc. Okay, so let's suppose we'll say African Americans, 0.25 fraction, Caucasians maybe 50%, Hispanics maybe 0.2, and Asians 0.05. If I'm not mistaken, this basically normalizes it. So no matter how big your values are, it's really looking at the relative frequency between these. So in this case, Caucasians will be 50%, African Americans 25%, Hispanics 20%, and Asians 5%. Okay. So that's the distribution here. And we want to build early, build often. So we want to do build to make sure it's happy. And it's in a state that when I was young might have been called hunky-dory. Okay, great. So now with the population as a whole, well, maybe we'll spend a bit more time. Who needs more time? Let me keep this up here. Again, it's 25% for African Americans, 50% for Caucasians, 20% for Hispanics, and 5% for Asians. Okay. Anyone need more time with this? Okay, let's go up to the population. And now we have to fill in the value to assume for ethnicity. We already have one for sex, where we picked with equal likelihood either sex. How about for ethnicity? Well, we can use this ethnicity distribution and just call it, okay? Here we can actually just call off to it, and it will return an appropriate ethnicity, okay, for us, just by calling it as a function. So in other words, I put the name of that distribution and followed it by begin paren, end paren. That's a sign it's a function. We're calling off to it, and it does its job, returns us a value, okay? So it's as if we call the sign function, hence the parentheses. Sign of 10, you put parentheses around it, right? Okay, fair enough. And then what are we going to assume for those currently in the population as to the mother? Well, we're going to do a strategy that might be known as punting. So for these, we're going to, for those who are in the initial population, we're going to say, okay, we're not going to try to impose a mother for them to try to avoid worrying about, okay, we make A B's mother and B A's mother and stuff like that. So we're just, for this initial people, we're going to punt on that. It's when we add people into the population that we're going to be able to establish these connections. And there's going to be some burn-in period for the model, whereby the population turns over and we have more and more people who were born into it and therefore have endogenously represented mothers, have mothers in the population. Okay? So for this initial population, we say null. And that means we have no particular mother specified. It's Java's way of saying, I have no particular value specified for this, okay? It's specifying no value for this. It's like saying not available, okay? The mother is not available. Okay, ladies and gentlemen, shall we run this? Let's build. You notice that null is spelled N-U-L-L, okay? Occasionally you see variants of it, N-U-L, and it's not the same as nil, N-I-L, which is not part of Java. Okay, here we go. We go look, and we can go down and see this. Yes, Kristen. Okay, TA. The TA is deploying to sector 1. Okay. So, does anyone else want me to show something on my screen? Should I show something on my screen here? Okay. Okay. This is the basic setup for sex, ethnicity, and mother. Mother is null. Ethnicity, we just call this distribution, the name of this distribution with parentheses, therefore we need after it, and sex is just random from. Okay? Who needs help? Okay, a professor is going to deploy to the sector 2. Yeah?
I lost my name.
Oh, okay. So this is simulations. That's actually the experiment.
Right.
So if you close that, double-click main, and there's main.
There it is. Okay.
Yeah. Okay? Okay, great. Okay. Great. Okay, so any questions about this so far? We're a lot of the way into this. Okay, so ladies and gentlemen, what I'd like you to do now is to go. We're going to impose a distance-based network, okay, on this population. How are we going to impose the distance? How do we connect people up if they're within a certain distance of each other? Where is that specified? It's in the network type, okay? So, and where is network type specified? In main. We scroll down, and we specify network type. It's going to be distance-based with a connection range, ladies and gentlemen, of 75. That's okay. So that's step 1 for displaying the network. What's step 2? So that actually imposes the network. There's going to be a network imposed in this way, a distance-based network. 2 people are connected if and only if they lie within 75 distance of each other in terms of their centers, their points of origin, which is located right up here at these crosshairs. So that's step 1. But how if we want to show that network? What do we need to do? We have to go to connections. So where do those connections live? It's the person's connections, not those connections shown in somewhat confusingly in main. It's the person's connections. Okay? It's the person's connections, and we need to set it so that there's a line between them. Okay, who needs help? Okay. Sure. You got it? Okay, okay. Sure. Sure. Okay. So, ladies and gentlemen, when we add a network, we can impose it on main by going down to that area that says network properties, and people are logically connected there. But to get them to show that they're connected, we go to these connections in person, and we need to scroll down and say draw a line connecting agents. They're logically connected without that. It's just it won't show it. It won't depict it. And I think some of the questions that came up yesterday about why isn't this network showing may have been because you have to distinguish in cases there's a network and it's just not being shown versus there's no network there in the first place. Maybe people aren't connected because the distance range is off. Okay? Okay. So I'd like you to now run this model. Okay. So we set a distance-based network with a connection range of 75, and we we set people to be displayed, and you should now see in your model people connected. Okay? Pretty familiar territory with the exception of this custom distribution. Okay, now we're going to go where it was a bridge too far yesterday, but we're going to go back with greater. Okay, so ladies and gentlemen, so I'd like to go now set an immigration parameter, which is going to bring home another point I made yesterday, but didn't note in the retrospective. So, I'm sorry, excuse me. This is going to live in Maine. Yes?
I need to go back to connecting showing the...
Yep, the connection. So that's shown in person. And if you click on connections, and if you scroll down to line between connections, yeah, to the line between connections, you should check that box here, right? This is in the connections field here. If you scroll down, there'll be a box for, there we go, okay. So you should be able to run it, and you should be okay. Okay, so ladies and gentlemen, we want to add now an immigration rate. Where is that going to live? Where would that most naturally live? We're going to add people to the population. Those people are not already in the population, but we're going to add them in at a certain rate. They're going to be coming into the population at a certain rate. Where would that live most naturally? In Maine. It's something having to do with sort of more aggregate information about the population as a whole, how frequently people come in. It's not related to any one agent. In fact, the immigration is arrival of a new agent, so it's not associated with a particular agent who's already there. So let's go to Maine, and then let's go add a parameter in that's going to be immigration rate, okay? This is going to be the rate of immigration, and I'd like you to give a default value to this that's going to be 10 people per month. Now, I noted that AnyLogic, through a rather simple mechanism, allows you to specify values. Although the time unit of this model is a year, it allows you to specify values in different time units quite regularly. This is going to be 10 people per 1.0 times month, okay? So this is how we'd write this. This what's in the denominator means 1 month, and it's 10 per 1 month. And it's going to, by using this sort of feature here, it's automatically adjusting it for whatever the time unit of the whole model is, year. And so it's going to translate that into 120 people per year, okay? So it's 10 per 1.0 times month. This is a nice feature. Sometimes in a given model, we'll have some things that are in terms of days. You know, maybe it's the length of a work week, or maybe it's, or the time till someone recovers from an illness. Other things might be in months, most naturally measured in months, and other things in years, etc. And being able to sort of give them in their natural units is handy, to not have to be able to give them in the form the original data is available, particularly if you were to use the description field to say where this data comes from, you know, from Smith et al. Or something like that, you know, 2007. It's nice to be able to give the data in the form that it originally came. So this is 10 per month, okay? We could actually specify, I was giving a general form, so if it was 10 per 2 months, I'd specify it like that. You don't actually have to do it, except month is sort of, conceptually it represents a unit. It's kind of like the yardstick of months, and so I like to say like 2 months or 1 month or what have you. You could just do 10 per and then month, and that would also be fine. It's highly debatable whether you should put 1.0 in there as to make it clear, whether it's clear from that. Is that helpful? Okay. So ladies and gentlemen, we have this immigration rate. Now, how are we going to capture? In what way? Using what mechanism are we going to capture people actually being added? Anyone? So how are we going to actually add these people in? So we have this stated immigration rate. We want people to come in with a certain frequency. How are we going to actually accomplish that? Okay, so it's going to be an event. Good. It's going to be an event. And because of some questions yesterday that came up with functions because they haven't covered them in the Java side yet, I'm going to go light on the functions this time. But we're going to have immigration event. Okay? Immigration event. And this is going to be an event, so it schedules certain things over time. And I'd like it to be well, you tell me what this should be. Okay, so rate, yeah. I guess if you have a parameter called immigration rate, it kind of suggests that, doesn't it? Notice a timeout would be suggesting a fixed time at which something occurs or occurs periodically. For example, for reporting, here we're going to have a rate, and the rate is going to be given by immigration rate. Okay, great. So we're going to have people coming into the population with a certain rate. Now, the action that we're going to undertake there, we're going to, in the ideal world, we'd use a function, but I'm going to introduce those probably today or tomorrow in my Java comments. For now, this is just going to be, we're going to add the person to population. How do we do that? Anyone remember from yesterday? Yeah. So in this case, we're going to add them. The population lives in this, so we could say this dot add population, and we're going to add this person in. This dot add population. Now, this is important because it may help spare you some trouble. AnyLogic automatically creates add population to reflect what parameters are taken by the person. Okay, so it automatically is going to take in parameters for the person. So if I do add underbar population, I do autocomplete, it shows me this thing with dot, dot, dot. If I click on it, if I double click on it, it actually expands it in two versions. There's the dot, dot, dot indicates there's two different versions, two or more versions. One is takes no parameters, and that would use default values as specified, or this value where it can specify the sex, ethnicity, and the mother explicitly. Okay, for this new population members, we're going to specify a random sex. So tell me what to say. I'm just going to pick with uniform likelihood from the sexes. How do I do that? You can do random from, and what do I type? I type, what's that? Sex, is it lowercase or a capital S? Capital S, because I'm asking for the values of all possible sexes. Okay? Random from sex values, so that's inside the call to random from. So it's evaluating what are the values of the possible sexes, and then for those, pick a random one. Okay? Great. Now, to prettify this, I'm actually going to go down to the next line here to sort of nicely line it up. So that's what we're going to use for that. Now, for ethnicity, we could go impose a distribution for ethnicity immigrant distribution if we wanted to, right? Because the immigrants who come into the population have a somewhat different distribution, and we could very easily do that. Or we could just say, okay, we know we can do it. Let's just draw with equal likelihood from the different ethnicities. Who would like to do an ethnicity immigrant distribution? Okay, no one? Okay, so let's just do random from, you know how to do it. We've done it before. Create a custom distribution. So let's just say ethnicity.values. We'll just pick it randomly from among the ethnicity.values. What I'm doing here visually, you don't have to do. You could put them all in one line, but I kind of like to line them up in this way because it's clearer. And then for their mother, we're going to, for the immigrants, their mother is probably outside the population of interest, and we're going to say it's null. Their mother might be in a place like Canada, right? And they're going to be outside the scope of this model. After all, you don't even have Inuit in your ethnicities. Okay, So,
I noticed that the population, the number of the person always starts at 0. And if you didn't want to add a parameter that told you that the person came from an immigrant and you wanted to be able to trace their history, could you create like a -1 person number so that you came from an immigrant?
Sure. So can I so I like where you're going with this, and I think it merits a little bit of additional discussion. Is it possible that we could do that after I finish the example? Because I think it lends itself to a more fulsome description, and there'll be something which we do in just a few minutes which will shed light on it and inform that discussion. Is that okay? Okay, great. So other questions? Yeah. Yes. Correct. And so, yes, thank you very much for highlighting this point. That's a big service to the group. And I stand remiss in front of you for not having emphasized this. When we call off the things in Java, informally yesterday I said that these things here, like you'll notice these things listed after add population. I said those are the things that add population needs to do its work. It needs some information to do its work. It's like, you hire a contractor to do some renovations in the home. They need information to do that, to accomplish their work. You give them that, and you agree to the payment, and they'll do the work for you. So it is with add population, but it needs these things in the same order. It's more picky than most contractors would be. So you have to give a sex first, and then you have to give an ethnicity, and then you have to give a mother. Is that helpful? Those comments? Yeah? Okay, so it has to be in the right order. And this will tell you the order. It says, give me a sex first. Give me an ethnicity, and then give me a mother. Does that make sense? Okay, great. Thank you for the feedback. Thank you for the good question. Okay, ladies and gentlemen. So here we go. So this is add population. And then the other thing we need to do, does anyone remember? We have to apply the network. This dot apply network. Okay? 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 So build early, build often. Make sure it's okay. I'm going to put this code up here. This is some Java code. This is non-trivial stuff, actually, in terms of the understanding it demands. I'm going to line it up. For some reason, the sort of alignment is off from what I have on my screen. So it's more like this on my screen in AnyLogic. That's kind of what I've got. So it adds the population. Java doesn't pay attention to whether there's a new line here. It just ignores that. It ignores spaces as long as they're not within the middle of like a name. And so here we have randomly chosen ethnicity, randomly chosen sex, randomly chosen ethnicity, and no specific mother, and then we apply network. Notice the semicolon. We're telling it to do something, not just compute a value, do something. And in order to do that, we have to end it with a semicolon. We're telling it, accomplish this, and it does it. We're not telling it simply compute a value like this. Okay, so two semicolons. Who needs help here? Who needs me to explain something? Who needs me to show this longer? Okay? Okay, shall we run it? Okay, build early, build often, run. Let's see things going on here. Okay, people are coming into our population. Lickety split. We've got people being woven into the network over time. I'd like you to remember what this looks like. You perhaps don't want to remember what this looks like, but pay attention because it's going to be different from something we'll see in a minute as we change to capture a different process adding people. Okay? So here we're adding people in. How could we see how many people are in the population right now? Give me two ways. Okay, what's that? Okay, we can click on this thing here. It'll say 1283 agents, 1290 agents. Another way we could go click down here, 1321 agent, 1346 agents. Well, our population is getting quite large. Okay. Okay. So note that visual pattern, unpleasant though it is, displeasing though it is. Okay. People being added in these sort of willy-nilly. Notice they're being added to the network. Okay. So we're in good shape. Open population for people coming in. The next step that we're going to undertake, we're much of the way through this little exercise. We're going to now go into person, and we're going to add in a state chart that's going to capture those same basic features we did yesterday. By the way, you don't have to represent, delivery of births with a state chart. I mean, you could represent it with an event within the agent, with going off at a certain rate. This person gives birth, for example. We're doing it like this for a little bit of extra clarity when it comes to some of the mortality processes and its interaction. So you don't have to represent it this way. There's many ways of doing it. I'm going to call this, what should we call it? Fertility Statechart, something like that. What I'd like to do is we're going to have two basic states. So one is going to be non-pregnant, one is going to be pregnant, non-pregnant, and then it's going to be pregnant. And again, we don't have to do this, but it does let us see a guard again. Pregnant, non-pregnant, and pregnant, and we're going to have a transition between them associated with conception, right? So someone becomes pregnant, and a transition back the other way associated with delivery, okay? So let's show the name, and we'll drag this down next to it. And then we should be able to create another transition the other way, which is associated with delivery. And let's show that name too. Give me another reason we saw yesterday, besides showing a name to make it more transparent, which is by far the most important. Give me another sort of fringe benefit, another perk, ladies and gentlemen, of showing a name next to it, of choosing this. What's a freebie you get with it? You see, when they're being displayed visually, you see the amount of time until the next, a given transition will fire. It counts down how long it will be till that transition will expire. You'll notice, ladies and gentlemen, I emphasize this a bit, but it bears noting. Don't do what I'm about to do, but if you drag this up, you'll notice that these indications of what nature of the transitions are disappears. If you drag it down, if it has space, it will show them. These things are useful to be able to catch errors in your model. Maybe you've forgotten to change it from a timeout transition, and it's actually useful to be able to see. This indicates a timeout transition. We're going to change the conception to be associated with a rate. But to spare ourselves some hassle that we had yesterday, and pursuant to David's suggestion yesterday, because we're going to have fertility rate and mortality rate be shared across people, we're going to put them in main, okay? So let's go down main, and then let's put in a fertility rate and a mortality rate. This is arguable, and some people feel fairly strongly about this, where these things belong in a model. If they relate to a person's behavior, they belong in a person. But we did see yesterday one really unfortunate side effect of that. If we put them in person, at a logical level, it kind of makes sense. They're grouped with person, but they don't vary between people. And then when a new person comes in the population, we have to specify them again, and it's just kind of a hassle. So putting them in main is another way to do it. Let's have a fertility rate associated with this of 0.03, associated with 0.01 0.25, okay? So 0.0125 and a fertility rate of 0.03, okay? Yeah? Yeah.
You just said that you put that information inside of person.
Yeah.
You cannot, if you are going to ask people, for example, the immigrant event that
Yeah.
happen in Maine,
Yeah.
you cannot access those rates from Maine to person.
Sorry, say this again?
You cannot have access to the information in those rates from Maine to person because in person you have an array list.
Oh, I see what you're saying. You're saying if they live in person, then you don't have ready access to them from within Maine. And that's true. That there are ways to provide. I mean, you can look in a particular person, but it's a very good point that if you need them in Maine, that's another motivation to have them in Maine. Very, very good point. I like it. Yeah. Okay. Any other questions about that? So we're kind of in the middle of creating this state chart. So we're going to have the conception occur at what do we have? What sort of transition is this? Will it be a message, a condition, a rate, arrival? In this case, it will be a rate given by the fertility rate. Now, how do we refer? We saw it one time yesterday. This is one of the basic skills I'm hoping to exercise here. How do we refer here to something that lives in Maine? If we want to refer to this fertility rate in Maine, how do we do that? We would say Maine dot. In other words, Maine's fertility rate. Okay, Maine dot fertility rate. Okay, that's what we're going to refer to the rate. By the way, where did this Maine come from? If you look up, it's provided to us. So it's automatically configured. Another way you'll see it occasionally written, this is the old way for AnyLogic 6, get underbar Maine, like this. You'd call off, hey, get my Maine, and request its fertility. A lot of the AnyLogic models will still use this. You'll occasionally see it in the models I've provided to you, certainly. Okay, so here conception is going to be occurring according to a fertility rate, and notice that the little icon changed to this sort of exponential distribution. This is a distribution associated with the residence time, and that indicates it's a rate. Okay, let's go to delivery, and this is going to be a timeout of make it 9 months. How do we write 9 months in this model? The time unit of the model is years. That's what we started with. If we wrote 9, would that be correct? No, we could write 0.75, but 9 divided by 12. Don't write 9 divided by 12. What would happen? What does that mean? 9 over 12, and actually it would evaluate to 0. Remember, it's Java's silly thing for your perspective that it says, how many times does 12 go into 9? 0. If you wanted to actually compute that, you would make it over 12.0. You make it a floating point division, not an integer division. So don't write this. But the better way to do it, more self-documenting way, would be to write 9 times month, like that. Okay? That's how we can indicate 9 months. So that's the timeout. Okay? Great. Okay. We're almost all the way there. It's great. This is terrific. Okay. But as I think Vahid over here said, Vahid had said yesterday, suppose we want this transition here to be guarded, to be captured so it only occurs for women. How do we do that within AnyLogic? Rehearsal? We put in a guard. And give me the guard to write. Sex equals sex dot female. I'm being a bit pedantic. We could probably do away without this, but it says female with respect to sex. Okay? And this equals means it's testing whether it equals that. And this is lowercase x, yes. It's talking about my particular sex here, my specific sex. Okay? Okay. Okay. So let's build. Okay, who needs TA help? Okay, TA help. Okay. Okay. Sex equals sex.female. Okay. Okay, great. So let's start as just a sanity check. Let's have it actually print out at the time of delivery a baby, a trace LN. So how would we have it print out when a delivery goes off that a baby will be born? Where would we put that? If we wanted to do that when this transition is taken, where would we do that? And the action associated with that transition, we could actually say trace LN, and we could say this has delivered a baby, okay? And what does that mean? It's referring to me, and it's going to take that as my name in the population. This is going to get back to Maria's question earlier about sort of people's ID, okay? So it's saying, so-and-so, myself, has delivered a baby, okay? Great. So if we run this thing, you should see these things coming out in your console. I'm going to put this up on the big screen in case you want to see it. Trace LN, this, plus, and then in quotes, has delivered a baby, end quote. Okay? Okay? It's trace LN. Yeah? Great. People comfortable with that? Yes. Okay, it's a good question. So the question relates to why would you put this associated with the transition as compared to, say, the exit action here? And I had mentioned this in passing before, but it's a point worth emphasizing. There is a difference. One is more specific than the other. So in this particular case, they're going to yield the same results. But in general, the exit action would be invoked regardless of through what transition you left. So suppose you had 5 transitions coming out of this. If we wanted it to print out for any transition I leave for this, we put in the exit action for the state. If we wanted it to be specific to a very particular transition, we put it in that transition's actions. And in a few minutes, we're going to add more. We're going to add more transitions out of this guy, and those other transitions are going to be mortalities. They're not going to be delivery of a baby. So we wouldn't want it to go in the exit action in this case. But in general, if what you want is to print out something when you're leaving the state, say you want to maintain a counter of the number of people who are at home right now, and this is the at-home state. When you leave, you want to make that counter 1 smaller. Then you would do that in the exit action rather than on a particular transition. Is that helpful? Correct. Yeah. Yes. Can they take? No, they cannot take time. They occur when a transition occurs. It occurs in an instantaneous way. And so you're in one state or another state, and the transition is itself instantaneous. It's a little bit like with stocks and flows in system dynamics, that there's a flow between them, but at any one time, the population members, they're not in the flow. They're not in this pipe. They're, at a given time, they're either in one state or the other. And so if you have a process which is going to occupy some time, time is going to be going on while they're in that, then I would put a state in transition or something like that, in transit, something along those lines, okay? Now, Maria asked yesterday, how do we print out the time? So let's do that. I had forgotten to put this, but let's add that, so has delivered a baby at time, and then we could do plus time. Notice we're calling time here to get the current time. So apologies, but it's a common need, and you want to print out the time at the end of it to sort of report when this event happened, okay? And that's how you get the time. And it will automatically sort of format it, etc. Okay?
I have a detailed question.
Detail.
So if I wanted to convert this time, which has like 10 significant digits, to just 2?
Yeah.
The Java question, okay.
Okay, a Java question. So there's a couple ways to do it. So there's some elements of the Java math library that basically have you able to essentially take a fixed number of digits from things. So I'm trying to remember. It's called math.round. Yeah, it's okay. So this rounds it just to an int or a long, which could be used for it if you were then to multiply it and then divide it by something. But there's a trying to remember the exact name, but yeah, there's a routine which will do it. You could certainly do it with round in order to kind of do it to an int. So if you want two significant digits to multiply, you do round of that times 100, and then you divide by 100, and that would work fine. But I'm pretty sure there's a routine that's actually like to fix it. And if it's not in here, it's in a Java library that you could trivially use with AnyLogic. Yeah. You could, but if she wanted it, you could use a custom formatter, and there are ways of doing that too, like printing it out with a very particular format. But if she wanted just as part of this to be printed with those digits, you'd probably actually want to convert the underlying number as part of that. Is that helpful? Okay, so other questions. So this should make sure it compiles, make sure it builds, and then let's run it, okay? So here we go. And here we have things happening, but notice that this thing is printing out that babies are being delivered here, okay, in the console window, okay? Who needs TA help? Okay, now we're getting very close here to the final elements. Okay, now we want a real action to occur. What action is going to happen when this delivery occurs? This is where the rubber meets the road. This is where the problems came up yesterday because we were calling a function, and it just got confusing and obscured the issue. So the essential things that need to happen here are twofold. What are the basic lines of code I'm going to add? At the point of delivery, what has to happen? Two things. Okay, you're going to add to the population, so the baby gets added to the population with certain characteristics. So what's the other thing? The network has to be annealed so that they're knitted into the network. Okay. Okay. So we're going to add them to the population. Who do we have to ask to add them to the population? Who maintains the population? Main. So we do main dot add underbar population, and remember this whole thing. It's going to tell us I need a sex, I need an ethnicity, and then I need a mother. Okay, so what sex will we use? Well, the baby sex, suppose it's just, it's a matter of random chance. So how would I describe 50% one, 50% the other? Random from, and then give me what to type? Sex.values. It's capital SEX because it's the sexes, okay? Now, I'm going to, again, use this kind of convention of putting down things here. And, in fact, I did this just a few minutes ago. It's very similar. Okay, but what's the ethnicity of the baby going to be? The ethnicity of the mother. And then who's the mother of the baby going to be? The current person, this. Okay, so we've added that baby to the population with the current person delivering it being the mother and with the mother's ethnicity. Okay, that's great. Oh, yeah, sure. It's nice. You could have done this at ethnicity. It'll be better. I really should be very consistent about how I do that. It is this.ethnicity. Java automatically inserts the this. If you don't mention it, it assumes it's for the current person, this.ethnicity. Sure. So I'll put this up here. There you go. Oh, sorry. Let me bring this back so it's nice. Yeah, it tries to be accommodating where it can, but as a general rule, it's inconsistent about allowing for it, and I just say try to reliably get in the mode of putting those semicolons, because it can spare you some grief in other cases. But the truth is, sometimes it will allow it. Yeah. But it's very important to have a distinction between what's a statement, something that's telling it to do something, versus an expression telling it to compute something. There are certain things you could do in a statement that you can't do in an expression. Okay. People comfortable with this? Okay. Okay. So, ladies and gentlemen, let's run the model. But before we run the model, let's create an alternative experiment. This is a very important principle. If you want to test if your model's running, it's best to create an experiment where you can observe carefully the particular process you've just added. And before we had all this immigration going on, there was all this stuff going on. It ended up looking like a big hairball, a big square hairball, if I may be so bold as to suggest it. And so here we want to, let's add an experiment without immigration going on, but with birth going on. And that will allow us to more precisely see what we've done and observe it. Remember, at building models incrementally, when I say build up a model incrementally, we're doing that right now. You build it, you run it, but run it in a way that allows you to specifically observe what you've added, the impact of that. That will let you spot bugs. It will let you spot unusual dynamics that are coming from that. So add a new experiment, and this will say no immigration, and you tell me, how would I change it? What do I have to change? Where do I go to make it no immigration? Riddle me that.
Immigration rate becomes 0.
That's right. Immigration rate becomes 0. Okay. Okay. So the immigration rate is 0, and we're going to leave the other characteristics the same. By the way, you notice a very nice side effect of having these other parameters in main rather than in person. Again, it's arguable, but having them in main allows us to capture the fact that we can then have experiments which vary the assumptions about fertility rate and mortality rate between experiments, rather than being trapped in person and not being able to vary them from an experiment. Because parameters in person are specified by what? By the population, or when you add the person to the population. And therefore, in general, you won't be able to specify in the experiment the parameters for the person. But if you have them in main, you could vary them between experiments. So here's a no immigration case. Let's run it. So compile, build, in other words, and run. We're running it, and here we see people coming in. People are being added to our model. These are new. These are people coming in, but there's something we haven't done yet. And what's that next step? Some of you mentioned it. We have to weave them into the network. Okay, so let's go to population. So who needs help? The TA is on the prowl. Okay, and how are we going to knit them into the network? Tell me what to type. Who do we have to ask to knit them? Main dot what? Okay, apply. You type APP control space apply network. Okay. So I did control space. Oh, I'm just in the delivery point of delivery, where we had the baby being added before. In person? Yep, in person. So main dot apply network. We're asking main to apply apply network. Apply network. Okay. So this is just after we added the baby in. We're going to apply the network. Okay. Okay. Shall we run it? See that impact? Okay, that's no immigration. Now we modified the model to knit them in. And now the babies coming in should be knit into their familial networks. Okay? Yep. Yeah. Yeah. So thank you. Let's see how many people there are in the population. 293. Let's go to someone 292 or something. Yep. Okay. So here's. Okay. So I'd highlight one thing here. So with delivery, did you have this here? Okay. So can you try? Could I take a look? Is that okay? Okay, great. So you have the conception, you have the delivery, and you have this, and that looks good. And let's go to no immigration, and let's run this thing, and let's have it run like gangbusters for a little bit. Okay, that's great. And then let's slow it down. Okay, fine. And that's 382, and let's go to person 381. 381, and
oh, there it is. I don't know why I had.
Yeah, it must have been. So some of the people. Oh, okay. Yeah, that could be. That could be. Yes.
Are people just being added in random locations?
Well, this is what we're about to say. Okay. Okay. So, folks, now we have babies coming into the population, but they're just being added in random locations. Let's go set it so the baby is close to the mother. Okay? So how are we going to do that? And this was, again, something that was made a bit more difficult by yesterday's arrangement of things. So, ladies and gentlemen, we're going to take advantage of the fact that this add population, it not only does something, but if you look at its definition, add population actually returns a person. And if you go look at its definition here, it said creates and adds this, and it returns the newly created embedded object. Now, in this case, the baby, at the point of delivery, it might be counterintuitive, but the baby is the embedded object. So this here is returning the baby. It's returning a reference to the baby. So let's go get a reference to that baby. Let's actually create a name for that reference so we can refer to the baby. So to do this in Java, you say person baby equals this thing. Okay, person baby equals this. And what that's saying is we're going to be able to use the name baby to refer to the baby. Okay? Now, I was in a very unfortunate situation in LA where I was emphasizing the name to use here, and I was referring to the baby, and it attracted note that I sounded like Justin Bieber, another unfortunate Canadian export. So anyway, let's keep the comparisons. Besides, he's an asset of your country now, not of ours. Wow, or a liability, right? Okay. In any case, so we give a name to this baby who's been added, and what we can do now is that allows us to refer to the information about a baby. So the first thing we'd like to do is let's have it print out information. So-and-so delivered baby such and such at this certain time. So I'm going to change this. So we could say so-and-so delivered baby and give the name of the baby at a certain time, okay? So I'm putting in this trace ln, so-and-so has delivered baby such and such at a specific time, okay? There we go. So this is the mother's name, has delivered baby such and such, and this is the baby's name. I should really divide this up differently. It doesn't really matter from the purposes, it's all correct, but I'm just going to put this so it's clear. I kind of like arranging it like that. I have delivered baby such and such at time such and such. Kind of logically groups it, okay? Again, it doesn't pay attention to what's on one line and what's on another. That's all for our sake, but This kind of as a logical organization. This line is about the baby. This line is about the time. This top line is about who. Okay? Are we okay with that? Yes.
So is that an instance of person?
Yes. Yes.
Is that a separate population?
No. It's a great question. No, they've been added into the population, so it's just creating a reference. It's returning, so it adds them to that population called population. If the population was called pop, you do add underbar pop. If the population was called city, you'd say add underbar city, and it returns a reference to the baby who's in that city now or in that population. Does that make sense? And now we can refer to this. Okay, so folks, should we go see the joyous news printed? What do you think? Okay. I know you wish you could include a photo too, right? Okay, so we're adding them in, and here we go. Root population has delivered baby root population 136 at time whatever. Okay, so you should see things like this in your console. Okay, while it's running. So and so has delivered baby such and such at time such and such. Now you notice this is pursuant to Maria's question that they all have this name root dot population such and such. Yeah, question.
I have an error that says baby cannot be resolved to result.
Oh, okay, great. Let's go check that out. Okay, so where does it say? Okay, and where? Oh, that's because this line has to be down below apply network. So in other words, below where you name the, actually it can be anywhere after you've named the baby, because if it's before it, it doesn't know about the baby name. Yeah. Okay. Yes.
So you're assuming that there's only one individual baby being born, and without complicating, how would the model like
twins? Yeah, we could do that. That's a great question. Oh yeah, we should have. Maybe. Well, okay. We're just about to reach a break, so that's good. Okay. Yeah. So if we wanted to have twins here, what we could do is at this point we could basically pick from a distribution, a custom distribution, how many babies are being born, and then it would just be a loop around this to apply them into a network. That's an important point. So folks, just to emphasize that point again, if we wanted to simulate twins, one thing we could do is we could draw, count of neonates, and we could draw from a custom distribution, the birth count or something like that, and then we'd have a loop for over each. It would create a baby, it would apply, and it would create each baby, and then it would apply the network for them. Okay, is that helpful? Okay, so and so it's delivered. Now note this line here, which uses baby, has to occur after we've defined what baby is. Java will be very unhappy if this is above here. Note by the way, Priyasri, this is a little nugget. So if I tried to put this line above there, Java will be unhappy because it doesn't know what this baby is yet. This line, because it refers to baby, it has to be somewhere after we've defined what baby is. Okay, we're almost done here, but we want to make the location of the baby be located near the mother. Okay, this is something we didn't see yesterday, but let's do it. Let's put the baby's location to be near the mother, okay? So we're going to set the baby's X and Y location to be a certain value, okay? And what I propose is that the baby's X location be the mom's X location plus some perturbation, some sort of slight deviation from it. So let's make the baby's X location, we're going to say baby.setXY because we're setting the X and Y location of the baby. And its X location is going to be drawn from a normal distribution with standard deviation 10. Unfortunately, it has that as the first argument, a normal distribution. You could see it here, normal, sigma, and then mean. So normal will be 10, and the mean, the value we'd want it to lie on as the mean will be the mother's location, okay? Get X location. And then the baby's Y location. Can anyone give me the formula from that? With the same principle? So the baby's X location will be centered on the mother's X location, but with a standard deviation of 10. How about for the Y location of the baby? It'll be centered on the mother's Y location. Yeah. Okay? So all I'm doing is I'm saying, I'll put this up on the big screen here. Okay, here we go. So the baby's X location will be, on average, the mother's, but with a standard deviation of 10 around it. So the baby will be a little bit offset from the mother. And the baby's Y location with standard deviation of 10 out, but on average will be the same as the mother's Y location. So it'll be located right around the mom, clustered right around the mom. And ladies and gentlemen, I want to emphasize, we want to do this before we apply the network. Why? What will applying the network do after this, then? If the baby is located close to the mom, who will be connected? The mom and the baby will be connected to each other. Right? Okay. So here, we've set the baby's location, and then we've applied the network. Okay? So, wow. This is quite a bit of little bit of logic here. We've set their X and Y location, then we've applied the network. This is their X and Y location. Who needs TA help? TA help? Okay, TA help is needed in the sector 1. Okay, all quiet in sectors 2, 3, and 4. Okay? Okay, so shall we run this? So build it, make sure it's happy, and let's run it. With no immigration case. So what's happening now? Can you see something different from how it appeared before? What's going on that's different from before? You get a lot more clustering. You get clustering in space. What do you think those clusters represent? Yeah, mother, child, and families. I mean, it's whole family lineages. So-and-so is the mother, or so-and-so is the mother, or so-and-so, so-and-so, and several generations back. Okay? So this is like 1,000 individuals, and let's go, So let's emphasize this right now, folks. Suppose we were to run the model for a while, and we were to pause it. So you don't have to pause it, but it will help perhaps speed things up. So if we were to go up a little bit, okay, there are 1,298 people in the population. I'm going to go view someone at the end of the population, 1,297. Okay? We number people from 0. Person 1297, their mother is person 613 in the population. Okay? So their mother is person 613. If we go look at person 613, by the way, person 1297 is African American. Their mother is person 613. Person 613 in the population, if we click on this, they're African American, which makes sense. Their mom's African American. And their mother is person 397. Person 397 in the population is also, not surprisingly, African American. Their mother is 295. Person 295 in the population, their mother is person 147. Person 147 in the population, their mother is 52. All of these are African American women going back. Person 52 in the population has no mother listed. Choose a member probably of the initial population cohort. Okay? Does that make sense to people as to what we're seeing? Okay. Okay. Yes. Yes, we're going to add that right now. Yes. Yes. Correct. Well, okay. So that person, so we'll see what that happens in just a minute, and we'll relate directly to Maria's question from earlier. And it will allow a sort of comment on that for about 5 or 10 minutes, okay? So that's what I'm leading up to. Okay, folks, so we had a bridge too far yesterday, but we have crossed that bridge well here, and we have this nicely going, hopefully with a lot less confusion. I'd like to add now a representation of death here, the death state. This is going to be, we've just added a final state in, and it's going to be called death. And we want to have a transition to death from both the non-pregnant and the pregnant state. And we want those transitions to be occurring at what sort of rate? At the, this would be called death non-pregnant, and this will be called death pregnant, something like that. I'm going to show these so that the names are shown. And what sort of transition shall they be? Think about what we have in the model. We had added some things relevant earlier in the model. What was it? A mortality. Remember, we added a mortality parameter. Where does it live? It lives in Maine. So tell me, what sort of transition will this be? It'll be a rate transition with rate given by mortality rate, right? Maine dot mortality rate, because it lives in Maine. Maine dot mortality rate. It's a parameter in Maine in this model. And the same thing with this other state. It's going to be a rate with this rate given by the mortality rate. Okay? And the final thing we need to do in that state representing death, we have to remove the person from the population. So tell me what to do there. So I set both of these transitions to be rate transitions with a rate given by Maine dot mortality rate. And then in that death state, what do I have to do? Can anyone tell me? Yeah, Maine dot remove underbar population. Who do we remove? This, the current person. Okay? Questions? Questions? Anyone want me to show any of this? Sorry? Yeah. There we go. Yeah, sure. Okay, any other questions? Okay. Remember, you can always get it to suggest the name by type REM control space and it will fill it out. Right? Yeah. Is there a way that it's auto suggest? You mean like beyond this? Yeah, without having the person. That's a good question. We're talking about it. I'm talking about it with the folks who do AnyLogic, including having it auto-suggest videos that would be relevant, or exercises or example models where this field is used, or where and so on. So yeah, we're talking about maybe having something like that. That'd be nice if it had maybe a pane where it had you could press. It would give suggestions what you might fill in at the current thing. If you're interested in that, I'd be interested in talking with you about it and maybe getting some ideas about what you think would work well. But yeah, we talked about things like that and sort of context-sensitive help. And another thing would be a link to a set of resources that would be helpful for that particular field, where models where it's been used, videos where it's used, step-by-step tutorials where it's used, etc. Yeah. Okay. So, folks, can we run this thing now? Oh, good point. AnyLogic 6 you don't have to, but AnyLogic 7 you do, we discovered. So yes, thank you. We do apply network. Thank you. Yeah. Okay. Apply network. This is what we need to do, those two things. You have to tell it, hey, apply this network so that this person is recognized as removed from it. Okay?
I didn't type that, and it was happening automatically.
Apply network?
I didn't type it before, apply network here, and I ran it, and people were disappearing.
Okay, that's really interesting. That's what would happen in AnyLogic 6, and I'm not sure. That's very, very interesting. Okay. Yeah, that's possible. Okay, folks. So now we have a situation where people are being born, people are disappearing. You notice that as we run this thing over time, without immigration, we have a very different pattern appearing than before. Much of the population much of the family structure of the original population has died down. Families go out of existence. Certain families survive and flourish while others have disappeared. And you see fairly delineated family structures here. And, you know, time marches forward here. Okay, so at this point, we're going to pause the model, and I'm going to go address some of the questions that came up from Maria and Vahid. So suppose we were to go look now in our model, which has 479 people in it, and I'm going to go look at person 0 in the population. Now, this is very important. Who is person 0 in the population has been changing over time. There's a set of people that are the same. It's just like if you go in line, does North Carolina have a Department of Motor Vehicles? If you go in line and you go to Department of Motor Vehicles, you're giving out numbers, right? When you go in, you take a number, maybe? I don't know if that happens here. You take a number, and you're waiting with that. Who's assigned to number 0 is, you know, a given number is going to change day to day to day. But, you know, those people survive day to day to day. They're not going out of existence. It's just a matter of naming them. Who happens to be called number 0? And similarly, if you go wait in line for, for food from a food truck, you're number 3 in line, and soon you'll be number 2 in line. Soon you'll be number 1 in line. You haven't changed, but the designation of you has changed, whether you're 3rd in line, 2nd in line. And so it is with who's 0th in the population. It's actually renumbering who sort of is at different points in the population. And you'll notice here, this is person 0. They might have been person 50 at the time the model started, but actually they were not part of the original population. You notice their mother is given as root population -1. This directly relates to Vahid's question. Their mother is no longer in the population. Why do you think she might not be in the population anymore? She was once in the population, otherwise it would be null. It would have been null. It would have been grayed out. But here it's given as -1. Why would it be? She died. She's died from the population. She's been removed from the population. Remember, when someone dies, we tell them to remove from the population. But we still have information on her. She just doesn't have a name in the population anymore. But we could still extract her information. We could still find out all sorts of information in her. She's just no longer in the population. Her information is fully accessible as a person. It's just she doesn't happen to be any longer in the population. So we could actually go and we could find out aspects of her history that she's recorded in it. She's just no longer in the population. Why is it kept? Normally people would, when they're removed from the population, they'll disappear. It's because we have a reference to them that's actually stored. We have this mother thing which is referring to her, and as a result, unless we go and we say, okay, all children no longer have a mother when their mother passes away, they're going to still reference her as their mother. It's just she won't be in the population anymore. So the population size and the population composition is not the same as the size of the number of people that are known about in the model, or the set of people whose information is being maintained by the model. It's just those people in the population. Okay, so here, if someone is removed from the population, we could still extract information. Now, if we don't want to, and this will be building up memory over time, we're going to have more and more and more people, many of them no longer living, but where we have their information. If we don't want that, we could always say when a mother passes away, all her children, have their mother set to null, to nothing, in which case her information won't be maintained anymore. Java has what's called a, and in this context, it sounds very cold-hearted, but it has what's called a garbage collector, and it goes through and it gets rid of information about things that are not needed. And one of the things to be gotten rid of is information about people who have no references to them anymore. But here we do have references. We have references in the form of this reference to a mother. And so you want to be careful, particularly when you're working with these models where people refer to one another, to distinguish between those. Now, I believe, I'd have to double check this, but I'm 98% certain that if instead of having that person was, if the mother is captured in this parameter, it's going to keep her information around. But if you instead just have the mother referred to as part of one of your connections, then the mother, if the mother is removed from the population, that connection will automatically disappear. Okay, so that's the difference. If you want to keep around persistent data about people who are no longer part of the population, you can do so by having a variable or a parameter that refers to them. If you just want to keep information about people who are in the population only, and you want it to be, that information to be automatically removed when a person is gone from the population, keep it in the connections. And you can have more than one type of connection. You'll notice that that you can actually add in other links to agents as well, family connections, workplace connections, connections through that involve certain type of health risks, like needle sharing. You could all have different sets of people. So if you want to maintain references to people that are automatically cleaned up when those people leave the population, do it in a connection. If you want to maintain references that are persistent, do it here. But I still haven't answered fully, I think, Maria's questions. That's all well and good, but it's a little bit interesting that people's designation changes over time in the model. Who is person 0 in the model, changes over time. Can we have a persistent name for someone other than a reference to them? Can we have an ID for them? And I will show you that now. Okay. We're going to show how we can add an ID to this model. I'm just going to save this.